Hey everyone, I wanted to go over a little bit about the project tree here. This is just a review. We went over this a couple times in class, but I feel like sometimes it's good to back up and have a little review. So if you'll look right here at a project tree, I'm going to start with the I/O configuration. If we open this up, this is where we're going to go in and do the read I/O config. And right now I've got this set up for a 1747 L532 with a 503 CPU. That's a SLC 500. And if I was to have this hooked up to a PLC, which I do not right now, and hit read I/O config, it would automatically fill in what card I have, what input and output cards I have accordingly. And right over here shows some of the module if you wanted to manually put them in. If you knew you was working on a project and you're going to use this, let's see, say you're going to use this 16-bit discrete input module, you'd put that in there. And the next thing you're going to use is a 16-bit discrete output module, and right here's the module part number. That'll be important to always note what module you're using. You could set it up like this, but it's best just to establish communication and do the read I/O config. That way you know what you got. But if you wanted to set up a project ahead of time, you could definitely pick what modules you're going to be using. All right. Now the next thing we want to look at is our data files here. We have talked about all these in the past, and we're going to go over them again. This O0 is your output tag file. You can go in here, and I told it that we were going to be using that output card a minute ago, so it's automatically put the card in here just like I was to be hooked up to it, like it could see it, even though I'm not hooked up to a PLC. So we've got a 16-bit output card in here. And if I was to go up here to the I/O configuration and pick another card, let's pick this analog card here and go to our output file card. And now you can see not only do we have an output card in slot 2, we also have an output card in slot 3. So it's going to show all of your card information for your outputs and all your data files in that file. Same goes for the input. If you open it up, it shows you all your inputs available, what cards they are, and what slot they're in. You can go between binary and decimal. Decimal for this situation here, for this input card, you would most likely read that information in decimal. But for this output or this input card right here, this discrete input module, you're most likely going to want to view that in binary, because that's where you're going to see your discrete on and off inputs. The next thing we're going to look at is the status bit. If you'll remember, a few weeks back we used a status bit for a flashing light. What we were using was the S4 status bit. That's a free running clock. If this was online with a PLC right now, you'd see ones and zeros just continuously changing, because that is a free running clock. The next thing is binary, B30. We've talked about that quite a few times. That's an internal bit, a dummy bit. It has also been considered a dummy bit for your program. If you want to turn on a bit to utilize it somewhere else in the program, right here's where you would see that internal bit. T4 timers. So if you open up your timer tag file, you see T40. We don't have any addressed on here. If we was to use a T41, it would place it in here as well. And here are your bits. That is your enable bit, timer timing bit, and a done bit, preset, and accumulated values. So if we were online with the program right now, you would see the accumulated value and the preset. And if we had a timer in here, you'd see if it was done, enabled, or timing. Another thing is if you're programming, let's throw a rung in here and we'll put a timer in, TON. We're going to go with 1 second with a preset of 5. So it's a 5-second preset. All right. So if we're programming right now and we go into the T4 timer, see now we see that we've got a 5-second preset, cumulative value of 0, and here's our bits. Well, let's say for instance we want to use one of these bits to turn on a light bulb. Come over here. The way we would do that, we're going to pull up our tag file and we're just going to grab the done bit. We want the done bit to turn on a light bulb. We're just going to grab that done bit and drag it up here and drop it. Actually, it needs to be the T41. Did you see it turn green? You have to make sure it's green before you drop it or it won't work. Okay, the same goes for your output tag file. We said we wanted to turn on a light. We know that a light would be an output to energize that light. So we're going to use this discrete output because we know these are all analogs. But this is our discrete. We're going to use our discrete output. First one available is output 20. And that's going to be our light. I like the drag and drop method. It's easier that way you don't have any typo errors or anything like that. It's pretty good. Same goes for an input. If I decided I want to put an input here to turn on this timer, I could open up my input tag file, utilize the first input that I have available or whatever input you would want. We're just going to call that start. I just wanted to remind you guys of the drag and drop. It's useful. These files are extremely useful. So we've talked about the outputs, the input, status, binary, timers. Now the counter. Counter's similar to the timer. If you wanted to put a counter in here, you could use any of these bits. You can look at the preset of the counter. You can look at the cumulative value of the counter. And if you wanted to address a counter, let's say we're going to put a counter in here on this next rung. A count up. So I'm going to go in here and I say, well, I don't know what counter I have available. So we can see here we got C50 available. Bring it up here. That's an easy way to address it. That way you know you don't have any typos. Preset value, 5 counts. All right. Same goes for the counter. If I wanted to turn this on when this counter goes done, instead of the timer going done, I would come in here and I would take the done bit from the counter. I would take the done bit from this counter. Maybe. Well, for some reason it's not letting me do that. Let's just do this. Let's add another rung since it's not wanting to cooperate. And we're going to say we're going to turn this light on when the counter goes done. And we're going to use the output tag file. We're going to use a 1. Alright, so now we're using this counter to turn on the second light. So we've talked about our timers, counters. Another thing that we've talked about in the past is N7 integer. If you'll look at the N7 integer, That's just a file where you're storing information, a decimal integer. If you look at it in binary, that's a word. All 16 bits creates that word. All 16 bits creates this word. And that's just a file for storing a decimal number. That's pretty much all we've talked about so far. Your R6, that's a control. That's for like if you're shifting and doing other things with the program that we haven't got into yet. So don't pay much attention to that right now. And the R8 reserved, we don't even have access to it on this model of the Slick 500. I've got a little worksheet that I want you guys to do, so when you get done watching this, the worksheet will coincide with what we've talked about. Just fill out the worksheet and don't worry about the R6 and the R8 reserved on the worksheet. Just fill out the other information.